Well, today we're going to have some fun with some classD. If you've ever bought a Chinese or are thinking about buying these very inexpensive Chinese classD amplifiers, they work. However, they have some design flaws that can be very inexpensively fixed. So one thing is, if you download the Infineon papers of what this circuit is designed on and what is recommended by the International Rectifier, which is Infineon right now, is close, but it's a little bit off the mark on some things. They cheaped out on the output MOSFETs. So there's a dead time circuit. So what they did is put some cheap MOSFETs in there and set the dead time to a maximum. I don't know, the difference in price is maybe about 50 cents. Maybe $1, I don't know. But the proper ones that they suggest are a lot faster, so the dead time doesn't have to be set to the maximum, so you can set it to a better performance level. The other thing is there's a cap in here, the ceramic cap that they put in there. It's a really tiny one. It should be a 400 volt. It says right there 400 volts. This size here, it's clearly not that. It's a very small cap. So it should be the 1200 size. Underneath the heatsink, you can see that where the dead time circuit is right here. So that there's a resistor that's missing here. And that's this resistor here. It's a 10K. We got a 10K and a 10K. That's the difference there. And then there's an improvement which you can do on top of this circuit is the coil and capacitor for filtering out the high frequencies is a two-order filter. I redesigned the filtering to go to like a fourth order, and with the two-order filter, you're getting about a half a volt of high frequency noise. And with the fourth order filter, as you can see running right here, I'm getting only 20 millivolts of high frequency noise from the switching circuit. So that's that. Other than that, I will create a video on how to do the modifications to make this work like it was intended by the manufacturer of the IRS2092